Let's look at this episode of Modern Maths. Ravi forgot a telephone number which he wanted to dial. However, he remembered the following details about it. The number was a 7-digit number. The digit 1 appeared exactly once in the number. The other 6 digits were three non-zero digits, each appearing exactly twice. What is the minimum number of different numbers that Ravi would have to dial to be certain of dialing the right number? First, let's try and see what sort of number it will be. It will be 1 AA, BB, CC kind of number. Not that the digits will appear precisely in this order, but it is 1 AA, BB, CC kind of number. These two are repeating, these two are repeating, these two are repeating. Now, which digits are repeating? In how many ways can we select them? We have to first identify, see, digit 1 is used up, it is coming exactly once. And the other digits that are coming are non-zero. So out of 10, 2 digits are gone. So out of the remaining 8 digits, we have to identify 3 which are coming in the number. 8C3 we have identified. We follow it up by, now these 7 digits that are identified. These 7 items, in how many ways can they be rearranged? They can be rearranged in 7 factorial by 2 factorial, 2 factorial, 2 factorial ways, on account of A being repeated, B being repeated, and C being repeated. Now 8C3 is 8 into 7 into 6 divided by 6. So 56 into 7 factorial. I will write it down as 720 into 7. I know 5040, but I don't know how many people know 5040. So I'm going 720 into 0. So this cancels, gives me 90. So now I've got 56 into 63. 56 into 630. Hopefully at this time, you can rule out B and D. And at this time, you can also potentially see 50 into 600 is 30,000. 50 into 600 is 30,000. Therefore, answer has to be A. Basically, after reaching this level, I don't expect you or want you to do the maths of it. If it has to be among the options, either it is not, that number is wrong. If it is wrong, everyone gets marks. If it is not wrong, then you know what answer it can be. Keep an eye out on the options always. That is extremely useful. Next question. 250 students took CAT test having 3 sections. 230 cleared section 1, 190 cleared section 2, and 140 cleared section 3. How many students at the least cleared all the 3 sections? Okay. Cleared all the 3 sections. So let's see, I have how many flags or chocolates or whatever is popular these days. 230 plus 190 gives me 420. 420 plus 140 gives me, I have 560 flags. And I have 250 students. I want minimum number of students to clear all 3 sections. If I want minimum number of students to clear all 3 sections, I would want these 250 students that are there. Basically, in my language or in my interpretational world, I want minimum number of people to be carrying 3 flags. I want minimum number of people to be carrying 3 flags. And I have to ensure I end up distributing these 560 flags. So the best way I can do it is, let me give out 2 flags to all the 250 kids. 500 flags will get exhausted. 500 flags are exhausted, yet we are left with 60 flags, and these flags also have to be given out. And to whichever person these 60 flags are given, that person will now have 3 flags. And therefore, answer to this question is C. In case you are not familiar with this, it will be A plus B plus C is equal to 250, or A plus 2B plus 3C is equal to 560. And now, given that we want to minimize C, we would want to fit everything within variable B. But that would only lead to 500. So we have to necessarily give 60 to C. We have to necessarily give 60 here, 190 here, and then see the equation at the bottom is balancing. 60 into 3 gets me 180 here, and 190 into 2 gets me 380 here. So yes, life is chill. We are getting 560. We are happy with it. Okay, next. A committee needs to be selected from 11 members. To avoid any ties during the vote, during a vote count, the number of members of the committee needs to be odd. Any odd number up to 11, up to all 11. In how many different ways can the committee be formed? Okay, pay attention. 11C0, 11C1, 11C2, 11C3, 11C4, 11C5, 11C6, 11C7, 11C8, 11C9, 11C10, and 11C11. These are the different ways in which they can be done. Hopefully you remember NC0 plus NC1, blah, 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 up until NCN. This is equal to 2 raised to the power n. This is a result that we know. So when we've got this entire list, can you see this is as good as 2 raised to the power 11 ways of committing any number of members in the committee. But we have been given the limitation, it has to be odd. Additionally, the other property we should know about NCR is NCR is equal to NCN minus R. So can I say this is equal to this, 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 this is equal to this. And because now we are only considering half these cases. Can I say this is gone, and 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 this is gone. But from each of these pairs, one case is left. So can I say from the total, half the count has been removed? From the total, half the count has been removed, and therefore my final answer has to be 2 raised to the power 11 divided by 2, or option C, 2 raised to the power 10. This is how theoretically it should have popped in your head. And see, my explanation requires to write all this, but in the exam you can directly jump to, okay, half of total number of cases, so 2 raised to the power 10. In case you want to go down the path of doing it a little more slowly, it will be 1. This will be 11. 11C2 will be how much? 11 into 10 by 2, so 55. This will require my time and effort. Let's go. 11 into 10 into 9. So 11 into 15 by 6. So 165. 11C7 will be 11 into how much? 11C4, no? So 11 into 10 into 9 into 8 by 24. So cancel 3. So this will be 330. And finally this here, 11 into 10 into 9 into 8 into 7 by 120. So cancel and cancel, I get 6. 6 into 7 is 42. 42 into 11 is 462. So let's do the math. 462, 330, 165, 55, 11 and 1, so 12. So if I add these up, 2 plus 5 plus 5 plus 1, 4, 1 carried over, 1 plus 6, 7, 7 plus 3, 10, 10 plus 2, so 2, 2 carried over, so 1024. So yes, we know this number to be equal to 2 raised to the power 10. Then we mark 10. Hopefully you realize calculating every individual item is not wrong, but it is slightly more cumbersome. And therefore, the conceptual understanding of what happens with NCR would be better here. Next question. In a school having 400 students, 200 play cricket, 250 play football, and 150 play hockey. Okay. If 100 play cricket and football, 80 play football and hockey, and 120 play cricket and hockey, find the minimum number of people who do not play any of the 3 sports. Okay, this is a constrained maxima minima setup. Let me record all the appropriate information. I have cricket playing people 200. I have football playing people 250. And I have one hockey playing people as 150. I have 100 people playing cricket and football. So 100. I have 80 people playing football and hockey. So 80. And 120 people playing cricket and hockey. So 120. And now I'm supposed to maximize the minimize the number of people who do not play any of the three sports. First, I take this region as X. This becomes 100 minus X. This becomes 120 minus X. This becomes 80 minus X. So this turns to X minus 50. This turns to X minus 20. This turns to X plus 70. You can do your maths. There is a way in which I reach these results slightly faster. I only take care of, see, 200 minus 120 minus 100 gives me minus 20, and X will normally come out. 250 minus 180 gives me 70, so plus 70. 150 minus 200 gives me minus 50, like that. So do the numeric part of it separately, algebraic part of it separately. Life is simpler. So now I've got 200 here, 70 plus 80, 150 minus 50, so 100. So 300 gone. So 300 plus X. Within these three circles, 300 plus X is represented. So outside the circle, it will be 400 minus 300 minus X. So outside region is given by the expression 100 minus X. And now my target is to minimize this number. The insight or the thought here that we have to take care of is each of these regions, each of these spaces represents a whole number. You cannot have minus 3 kids playing any sport. You cannot have minus 7 kids playing football. That is not possible. Each of these regions represent whole number of people. So simply look at all those regions where you have X minus something. So we have X minus 50, X minus 20. Can I say X has to necessarily be greater than equal to 50? Otherwise, this region here, number of kids who are playing only hockey would be a negative number. That is impossible. Similarly, look at all the regions where we have something minus X. You have 100 minus X, 120 minus X, 80 minus X, and 100 minus X. Can I say X has to necessarily be less than equal to 80? Because if X is not less than equal to 80, let's say X was 90, then the number of kids playing only football and hockey would be minus 10. That is impossible. So we've identified a range of values that X can take. X can range from 50 to 80. These are the possible values of X. Now, when the question is asking you minimum number of people who do not play any of the three sports, effectively, question is telling me minimize this number. In order to minimize this number, X has to be maximized. So if I take maximum possible value of X as 80, it turns into 100 minus 80, or the answer will be option A, 20. Okay. Next, if all 4-digit numbers that can be formed using any of the digits 1, 2, 3, 4, 5, 6, 7 without repetitions are arranged in increasing order, which number will occupy the 500th position? Okay, let's start. First number, we'll start with 1. And now I have 6 digits left. So 6 into 5 into 4. So I get 120 cases here. So when I start with 2, I will also get 120 cases here. Similarly with 3 and with 4, I will get 120 cases and 120 cases. So far, we have gone up to 480 numbers. I'm not doing it with 5. I'm not doing it with 5 because then we would go to 600, but we only need the number at the 500th position. So now let me start with 5. 5, 1. Now we are left with 5 digits only. 5 is used up, 1 is used up. We are left with 5 digits only. In how many numbers will be created? 5 into 4, or 20 numbers. Added to the previous 480 cases that we had gotten. Now when we get 20 more cases, so yes, the last number, the greatest number or the largest number that is starting with 5-1 should be the answer. The largest number that is starting with 5-1, we no longer have digit 5, we no longer have 1. The largest number left would be 7 and 6 in the last two places. So answer to this question is option D, 5176. Hopefully you learned something. That will be all. Okay, bye.